Welcome to online lecture session of SVIST. Today the topic I am going to discuss is surface roughness. Surface is the most important part of any mechanical parts. The nominal surface appears as absolutely straight line, ideal circles, round holes and other edges, and the surface that are geometrical perfect. That means the normal surface of any mechanical part, it can be straight line, ideal circle, round holes and geometrical perfect shapes. The actual surface of parts, it is determined by the manufacturing process that is used in order to make that part. So the variety of process will result into wide variation of their surface characteristics. Why this surface is so important? So the main thing is the surface, it will affect the safety of that particular mechanical part or any part of the product. Friction and the wear, it is always depend on surface characteristics. Surface not only affect the mechanical properties, it also affect the physical properties. Assembly of parts is also depend upon the surface. Smooth surface will have always better electrical contacts. Surface texture. So what is surface texture? The topography and geometrical features of the surface is the surface texture. So in another way we can say, when we are magnifying that particular thing, the surface is anything but straight and smooth. So if you go through that part, you will find it will have certain roughness, waviness and flaw on that particular surface after the manufacturing process. So you will see in that particular part that it will follow a pattern and direction that results from the mechanical process that you have adopted in order to produce that particular part. So this is the certain image in which you can see the pattern of that particular surface. So you can see in this particular image picture, this part is called, you can see the crack, it is the crack, or we can say flaw, and this is the direction of the roughness. Okay, you can see the direction is in this direction, which means the machining is done in this direction. So the pattern you are getting the direction in this part, in this way. The crack, the flaw, the chatter is the any type of unwanted holes you are seeing in that particular surface. So this waviness, when this wavelength is more, you will have this waviness things, and this is the waviness spacing, and this is certain the waviness height. And when the roughness wavelength of this rough pattern is very small, then you have the roughness. So you can see in this particular, when it is magnified, this is the roughness height and this is the roughness width. So what is roughness? So roughness is very small, it is very fine space deviation from the nominal surface, and we can determine by the mechanical or material characteristics and the process that is formed by the surface. And waviness, the deviation which have the largest spacing, that is called the waviness. So waviness, the deviation which will have the large spacing, that will be waviness. When it will be small spacing, then it is roughness. Lay is the predominant direction or the pattern of the surface texture. Flaw is the irregularities that occurs occasionally on the surface. Okay, so that can be cracks, scratches, inclusions and the defect in the surface. Although some flaws related to surface texture, they also affect the surface integrity. So these are the lay symbols and these are the surface pattern of the texture. Surface roughness, basically it's a measurable characteristics based on the roughness deviation, and surface finish is more subjective term denoting to the smoothness and general quality of the surface. So if you look at this particular picture, you will see these are the vertical deviation from this mean lines, and this is the nominal surface. As I already said, nominal surface must be a straight line, and when you are seeing on the magnified images, you are seeing this, the nominal surface is getting deviated from the nominal surface. This is the roughness. So these are the vertical deviation, this is the actual surface, and when you are calculating, this is the center line. Center line, basically we can say, when you divide, make a line in where the below area is equal to the above area, then that line is called the center line. And mean line is the line that will define this total effective profile of the surface which you are going to see within the sampling length. The sum of the square of the distance between the effective points and the mean line should be minimum. Center line, again, it's a line for which the area embarrassed by the profile above and below the line is equal. Center line average we can find out by using this formula. It is the arithmetic average of the distance of the filter on unfiltered roughness profile from its mean line. Maximum peak to valley height is Rmax, and RMS value is denoted by RQ. You can use this formula in order to calculate the RMS value. 10-point height of irregularities, you have to take highest 5 points of the peak and highest 5 points of the valley. So basically it's the average difference between the highest peaks and 5 lowest valley. So it is denoted by RZ. So this is called the 10-point height of irregularities. So this is how we specify surface roughness, and we represent this is in this form. This value is giving out the maximum waviness height, and this value is giving you the maximum waviness width, and this above value is giving you the maximum roughness average, and below value is giving you the minimum roughness average. And here the value which is given below, that is the maximum roughness spacing, and above it is the cutoff lay. Now the method which we are using for measuring the surface roughness, it can be touch inspection. When you will see the surface roughness by your own hand, you can feel the surface, whether the surface is smooth or whether the surface is rough. You can see that by manual touch. Visual inspection, by looking at your own eye, you can see the surface and you can visualize the surface. Scratch inspection, also we can see the surface, whether the surface having any scratches or not. And by the help of this microscopic inspection, we can also see these things. So this direct method measurement, the stylus probe instrument, basically we use the skate or show this slowly move over the surface, and stylus move over the surface with the skate, and amplifying device for magnifying the stylus movement and indicator. A recording device is provided to produce the traces of this surface profile and a mean of analyzing these traces of the profile. This is simply one Tomlinson's surface meter, which is used for measuring the surface roughness. So this is the Taylor-Hobson telescope, which is used for measuring this surface roughness. As the probe moves, you can see the armature that is given here. This armature, okay, pivots through the E-shaped stamping, okay, and any movement of the stylus causes the air gap to vary, and the amplitude of the AC current is modulated, and the signal is demodulated to get the vertical displacement of the stylus.